Hello everyone. So, I'm just gonna start a new series where I explain a few concepts in math that I think are very important. Sometimes we're just given the definition, but we don't really understand where the answer are coming from. For example, derivative of inverse trig functions, we just are given those answers. We are just told that the derivative of sine inverse of x is this random formula here. Excuse me, I'm a little bit sick. The same thing for cosine inverse and then tangent. Well, but the thing is that whenever we ask students how they got these answers, they don't understand. Professors usually skip those, but these are very fundamental to the way we understand and solve problems in math. And because of that, I'm just gonna start a new series. I'm going over all of those and explaining why we have those answers and even the absolute value here. For example, for um, secant inverse of x. So let me get started. The first one I'm going to be solving today is cosine of inverse. Cosine inverse of x. How do we solve this? So one of the ways to approach this is by understanding that this is a function. Cosine of inverse of x is a function. That means that if it is a function, I can put it inside of a box, right? So I can put it inside of something and then try to solve for that. What I'm going to do is, what I know is cosine of x. I know many things about cosine of x, but I don't know anything about about cosine inverse of x. So what I can do is I can put this in the box, right? I can put cosine of x into this box. Let me call this box y. Now, what I'm gonna be doing next is just as I said, I don't like to work with cosine inverse. So what I can do is I can take cosine on both sides. So when I take cosine of cosine inverse, this will yield back x. So cosine of cosine inverse, my apologies, of x, this whole thing we evaluate to just x, right? So I end up with cosine of y is equal to x. Now remember, we're going to be using this eventually, that y, this y here, we had defined it as being cosine of inverse of x. So far so good? Yes. So now the thing is, okay, when I look at this function, I know that cosine, the input here is usually an angle. So that means that my angle is given the name of y. And when I see this, I know, oh, when I'm working with angles, I'm working with triangles, right? I'm going cosine and sine, I'm working with triangle. So this is what I'm going to be doing. I'm going to be drawing a triangle. And the triangle has the angle y. So my angle y here. Now, this is where the SOHCAHTOA comes into place. So I remember that I have the whole thing that I was taught in school, which is SOHCAHTOA, where I know that so stand for sine of an angle, let's say theta, is equal to the opposite side over the hypotenuse. And the same thing goes for so cosine of theta is equal to adjacent side. So I'm going to put opposite side here over hypotenuse and then adjacent over hypotenuse. And then for tangent, I know it's going to be tangent of an angle is equal to opposite opposite over adjacent. Lovely. So far so good. Hopefully it's making sense. I'm gonna move this on the side here and then put it inside of a box so that we can refer back to it later on. Red box, not so pretty, but it makes sense. Lovely. Because we're gonna get back to it right now. I know now that my angle, I have to use cosine, right? Cosine, we just say that cosine was the cosine of an angle is given by the adjacent side over the hypotenuse. Here, when I see x alone here, this is the same as just having x over 1. Which means that if my angle is theta, my opposite side, so the side opposite to the angle should be the one on top here. So that will be, sorry, my apologies. We're talking about cosine, so adjacent. The adjacent side to the angle, which is right here, should be x. and the hypotenuse should be 1 because we're using this formula here of cosine of theta is equal to the adjacent side over the hypotenuse. Lovely. Now, just to make sure, I want to figure out what this side is. And remember, this is a triangle, a right triangle, 90-degree angle here, which means that I'm going to be using, to find a missing side, I'm going to be using the Pythagorean theorem, what we used to, which is c squared is equal to a squared plus b squared. Assuming that this side is c, this side is b, and this side is a, I know that a is equal to x and c is equal to 1. Now, b is the one that I'm missing. I need to find what b is. I can plug those values here. So I have 1 squared from this guy here plus, no, sorry, is equal to a squared, which is now x squared, plus b squared. This is my first thing, but I want to solve for b. I want to solve for b, right? So I want to solve for this side here, b. So I can, what do? I can subtract both sides by x squared. So I end up with 1 squared, which is 1, minus x squared is equal to b squared. But remember, I said I wanted to find b. So what do I need to do next? I want to get rid of this square root of this power here. So I'm going to take the square root of both sides. So I end up with square root of 1 minus x squared is equal to b. Lovely. So that means that this side, which is the side opposite to the angle, is equal to, now I can rewrite it as the square root of 1 minus x squared. Lovely. So for my triangle, I'm all set. Now what I need to figure out is how to make this work, right? So I can just write this as x because I already have it here. Remember, it was x, we had x over x is x over 1, which is x, is equal to cosine of y. Now what I'm going to be doing here, which is a very interesting way of solving this, is I'm going to take the derivative on both sides, because you find out what you see what's going to happen when I take the derivative. When I take the derivative of x with respect to x, right? So x is here, derivative of x. I also have to take the derivative of this whole thing here with respect to x. When I take the derivative of x with respect to x, that gives me 1, because the dy dx, if y was x, it will give you 1, is equal to, now the derivative of cosine, remember, we can look it up if you wanted to, the derivative of cosine is negative sine. But here, because this is a function, so cosine is a function, so we have a function inside of a function, so we have to use, when we have cosine, we have to use the chain rule, sine, cosine, all of those, we have to use the chain rule. So when I use the chain rule, I end up with negative sine of y multiplied by the derivative of what is inside, remember the chain rule, but I don't know what this is. I know, remember, that I only remember that y is actually defined here on top. We have defined y as cosine inverse of x. Aha. So that means that I end up with dy dx, where now y, if I remember what my y was cosine inverse of x. So I end up with 1 is equal to negative sine of y multiplied by d cosine inverse of x over dx. Lovely, right? So now, this is where it's very interesting. Our initial question was to find this guy here, the derivative of cosine inverse of x, right? Now, I have that here. I have this guy here. What can I do? What I can do is, the one problem that I have here is this guy, sine of y. So what I can do is I can divide both sides by sine of y, and this is what's going to happen. I will end up with 1 over negative sine of y is equal to d cosine inverse of x over dx. Now we are all set, because what's important here to note is we know what this is. If you don't know, let's figure this out. We know that we have a triangle here. Remember our triangle? We found all the sides of the triangle. We have the side here, 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 and here, right? This angle is still the same. Now, what is the value of this sine of y? Remember, we also had these guys here to help us. Sine of theta is equal to opposite over hypotenuse. Okay. My angle, y, the side opposite to it is right here, which we just calculated, and the hypotenuse is 1. So that means that if I write it down here, my sine of y will be opposite over hypotenuse, and my opposite side we just calculated to be square root of 1 minus x squared over 1. So that means that my sine of y is equal to this guy here, which is just square root of 1 minus x squared. Now that I know this, I can just plug it back here to get 1 over, that was a long line, 1 over negative square root of 1 minus x squared, which is equal to d cosine inverse of x dx. You can, now I can, this is my final answer. This is my final answer. The negative here can go on top or the bottom. It will be the same thing, and I can just rearrange it to match my original question. So, which was d cosine inverse of x dx is equal to negative 1 over square root of 1 minus x squared. And that's it. That's my answer. That's how we solve this. And you can use the same process for cosine, for sine inverse, tangent inverse, cosecant inverse, and tangent inverse, and cotangent inverse. All of those will make sense to you, and I can do it in the next video, and if you want, I can do it with you. Thank you for watching.